Climate Change and Maize Production by Chris Dillon, John Hodgins, and Veronica Lee. What is climate change? Climate change is the long-term shift in weather and temperature averages in a given region. Global average temperatures have been trending consistently up. The 2022 surface temperature was 0.86 degrees Celsius warmer than the 20th century average of 13.9 degrees Celsius and 1.06 degrees Celsius warmer than the pre-industrial period average, 1880 to 1900. And this problem is only growing larger. The rate of warming since 1981 is more than twice as fast, 0.18 degrees Celsius per decade, and this could increase further in the coming decades if current emission trends continue. Underlying issues: unsustainable agricultural practices. The main underlying issue is unsustainable agricultural practices. A major issue is deforestation, which not only contributes to greenhouse gas emissions directly through the removal of the carbon reservoir stored in the trees, but the removal of trees also makes it easier for soil to be eroded as their roots are no longer providing a structure. A famous example of deforestation was the Dust Bowl in the 1930s in America, where massive dust storms swept through central and western states due to intensive farming and a lack of trees. Another unsustainable agricultural practice is the use of synthetic fertilizers. While beneficial to the crops, they kill the microbiome that typically is responsible for nutrient production in the soil, necessitating the need for more synthetic fertilizer use. Finally, crop monocultures reduce biodiversity and are vulnerable to rapid disease spread and climate change, endangering global food security. A famine caused by an over-reliance on crop monocultures could have wide-reaching ramifications for societal health, global stability and safety, and human population size.
As temperatures increase and precipitation changes, maize production grows worse and becomes less healthy. In the tropic regions where maize is usually grown, these rising temperatures will lead to an estimated 20% decline in yields. The changes in rainfall patterns due to climate change can cause severe drought or overwatering, which will damage the crops even more. In addition to the severe droughts, there can be a massive loss of water depth in rivers and lakes due to the decreased precipitation, and this has been shown in Lake Chad, Great Salt Lake, and Colorado River. The short supply of water drastically decreases maize production since there is not enough nutrients for them to grow. In addition to the changes in precipitation, climate change can also cause more severe weather patterns that can cause increased rates of soil erosion and degradation, further leading to the inefficient grazing lands for maize production.
An example of how climate change has impacted maize crop yields and other crop yields is shown in a study done in China from 1979 to 2016 by Xinli Wei and Zhang Jing, among other noticeable scientists, and basically finding that precipitation has a negligible positive impact. The probability of future increase in temperature in China are highly likely, and the overall temperature has a negative impact. This is shown by the data that we have here in the graphs here. Basically, in graph A, which is in the bottom left corner, temperature on the y-axis and year on the x-axis, there's a clear linear trend between the two, basically showing that overall the temperature is increased through the years and it can be expected to increase in the future. This is where the second bullet point comes in, where the probability of future increase in temperature in China are highly likely. The graph B, on the other hand, has precipitation on the y-axis and year on the x-axis, showing that there's a negligible change in precipitation in general, and therefore it has a negligible positive impact. In addition, the table here shows a bunch of variables: temperature, precipitation, fertilizers, etc. And as seen here, the coefficient is basically what tells you how much it affects, or the variable affects maize crop production. As seen here, temperature with a negative 0.025 coefficient and a generally high coefficient in the negative direction for all the models shows that it has a negative impact on maize crop yields. Precipitation, on the other hand, has a very, very small coefficient, therefore showing that it has a negligible positive impact. Now, what exactly does this mean in the future in terms of maize crop yields? So, according to a study done by NASA projecting maize crop yields in the next 10 years and also in the next half century, they found that in the next 10 years, maize crop yields will be down 24% and wheat crop yields will be up 17%. In the next half century, on the other hand, they made an image here showing basically how the percentage change expected in corn yields expected by 2071. The red shows a negative 40% change, basically, and the bright green, shows a positive 40% change. As seen in the image, there's a lot more red and yellow area than there is green area. Thus, there will be a very high decrease in corn yields. There was also a study done and research done in the North China Plain, basically showing how the increase in annual mean solar radiation would lead to elevated temperatures, which in turn also leads to accelerated crop growth and shorter crop growth periods. This basically means that with accelerated crop growth, you can grow your crops faster. However, there's a trade-off to that where with the shorter crop growth periods, you don't have as long or as big of a window to grow these crops. So in all, in the next 10 years, we expect our maize crop yields to go down significantly while our wheat goes up. And in the next 50 years, we can expect to see drastic changes in the production of maize or corn yields and perhaps in other crops as well. Here are our works cited for this.